Hello everyone, in this video we will be covering section 9.1. Chapter 9 is technically just a continuation of chapter A. So if you understood chapter A, then chapter 9 will be a breeze. If you didn't understand chapter A, then you pretty much have no hope here. So you need to go back and review chapter A. It's 99% the same thing. The main difference here is you have two samples instead of one, and that's gonna make step one actually a lot easier than it was in chapter A. For example, here the claim is the two means are the same, which means that there is no difference between the two samples. Now, if you reject the claim, then that means that there is a difference between the two samples. In essence, you're comparing to see if one is better than the other, but all we really want to check all of chapter 9 is whether the two parameters are the same or if there is a difference between the two. And obviously, if there is a difference, one will be better than the other ones. So therefore, all the questions we're going to do in chapter 9 are going to be two tails. So all will be two tails. They don't have to be two tails, but we will do all of them chapter 9 two tails, so that will make things a lot easier. Remember, two tails means that alpha is going to be divided by 2. Now, as you can see, the process is identical to chapter A. You have the hypothesis first, then you're going to have a test statistic. And you remember in 8.2, this star was equals to this. And this formula is technically taking place for this one. This is for one sample, and this one is for two samples. If you have a TI 83 or 84, you can compute a whole thing. You should check the handbook for the instructions, which are very easy to follow. Now, obviously, this formula is a little more complicated than this one, but it doesn't mean it's hard. It just will take you a little longer. You have to be careful with the calculator. Now, the rejection region in the p-value is 99% the same as before, as technically section 8.2, except that now the degrees of freedom is going to be the smallest n, the smallest of n1 and n2 minus 1. For example, if n1 is 12 and n2 is 6, the degrees of freedom is going to be 5, because the smallest n is 6 minus 1 will give you 5. Now the p-value is the same as before. Since this is two tails, you multiply by 2. Okay. You can use a table and approximate with a table. Okay. Or you can use a calculator. This is the command that will give you the precise value. Remember, this is an approximation. This is the exact value. And then the conclusion and summary is very similar to what we did before, except that I had two samples. So there is only two choices. You either reject HO. So if you reject HO, that means that there is a difference between the means, between mu1 and mu2, or that there is evidence that there is a difference. And if you fail to reject HO, that means that there is not enough evidence to reject the claim, but that doesn't necessarily make the claim true. And we went over this before in chapter A, so remember that if you reject this, then automatically this is true. But if you fail to reject, That just means there is not enough evidence to reject it, but it doesn't make this one necessarily true. All right, so let's do an example and see how this works. You will see that the process again is identical to chapter A. Obviously, the main difference is, remember that you have two samples, and that's how you will know you're in chapter 9 and not in chapter A, because there is two samples. So it will be two samples, two standard deviations, and two means. And you're always checking to see if the means are the same or if the means are not the same in this section. All right, consider the following example. So this information is already given to you, and the claim is, I told you, that it's going to be the same all the time. Are the two means the same, or is there a difference between the means? Here we have the first sample, and this is the second sample, and this pretty much has to be given to you, or it will be pretty easy to find using what you learned in chapter 3. But in a test, this will be given to you. All right, so here step 1 is already given to you. So now for step 2, you need to find the test statistic, which is test star. Remember, test star is x1 bar minus x2 bar over the square root of s1 squared over n1 plus s2 squared over n2. Just plug in the values and just be careful when you use the calculator. So this will be 72 minus 69 over 7 squared over 14 plus 12 squared over 22. You should stop the video, get your calculator, and check that this is around 0.9095. You run it to 2 decimal places. Next, you need to find the rejection region. So make sure you have the T table. Remember, the rejection region is going to be T of alpha over 2 degrees of freedom, which in this case it will be T of 0.025. Now remember, the degrees of freedom is the smallest, that's what minimum means, of n1 and n2 minus 1. In our case, the smallest n is 14, so this is 14 minus 1, which will be 13. So therefore the rejection region will be T of 0.025 with 13 degrees of freedom. Then we need to find this on the T table. All right, so we need to look to 13 degrees of freedom, and alpha over 2 is 0.025. So that will give us this value right here. Remember that this is a two-tailed test, so therefore the rejection region is going to be both the left and the right. So in our case, this has to be plus or minus this, which will be plus or minus 2.160. Then draw the rejection region. So we have 0 here, 2.160 there, minus 2.160 is here. This part, and this is the rejection region. So again, this is identical to what we did in chapter A. And this part right here is fail to reject HO. Then you look to step 2. From step 2, this star is 0.95. Now 0.95 is somewhere here. 0.95, which clearly is not in the rejection region. So therefore the conclusion will be fail to reject HO, which means that there is no evidence to reject the claim that mu1 is equals to mu2, which remember meant no difference between the two means. Also, just like in chapter A, you have a choice to do the rejection region or the p-value. Remember, for the p-value method, step 1 and step 2 are the same, so you don't have to write it again. Step 3, the p-value is going to be twice the probability that t is greater than the absolute value of t star, which in this case is 0.95. So I'll show you these two ways, using the calculator and then using the table. So let's do the table first. Don't forget that we have 13 degrees of freedom, which is this part right here, and we're looking for 0.95. Now 0.95, if it was in this table, you will want to place it here. It will be somewhere here. Remember, if the number was here, you will pick something between this and this. If the number is here, you pick something between 0.25 and 0.50 and so forth. And remember, this is an approximation only, but that's enough to complete the test. If you are on this side, you should always, to make your life easier, always pick 0.2, and you should write this in your table. Therefore, the p-value is going to be 2 times 0.2, which is the value we just picked, and this is around 0.4. Remember, the last step is to compare the p-value, which is 0.4, with alpha, which was 0.05. Clearly this is bigger, and by the decision rule that we have in the formula, which is the same we have been using since chapter A, that means fail to reject HO. Now if you want to use a calculator, so for this step, then this will be 2 TCDF. The lower bound is 0.95, the upper bound is 1000, and then you need 13 degrees of freedom. So this will give you 2 times 0.1797, which is around 0.36. And this is step 3. And step 4, we'll do the same thing. The p-value is 0.36, which clearly is still bigger than alpha, which was 0.05. And the conclusion is still fail to reject HO. So you have the choice to do the table or to do the calculator. All right, well, you didn't get that one. Let's do one more. This is the chance to redeem your sins. As you can see, this is very, very similar to what you did in chapter 8. In this example, we have the following. Burger King claims that the amount of saturated fat in their hamburgers is less than their McDonald's. So even though this is the claim of the problem, we're not gonna go with that. So you're always gonna do this first. So step 1, no matter what the problem says, is gonna be, are the two means are the same, and the alternative, are they different? Okay. And then once you do the conclusion, you have to go back and see if it agrees with this was saying. Okay. This is the information we have here. X1 is equals to 80. X2 bar is equals to 84. And 1 is 25. And 2 is equals to 20. S1 is equal to 10. And S2 is equals to 8. And alpha is 0.01. All right, so for step 2, you need to find T star, which will be 80 minus 84 over the square root of 10 squared over 25 plus a squared over 20, which is around minus 1.4923. So let's say this is negative 1.5. Now you should find the degrees of freedom from here, because we're going to need it in step 3. Remember, the degrees of freedom is the smallest n. So the smallest of these two is 20. So 20 minus 1 is 19. So that will be the degrees of freedom. So then for step 3, we need to find the rejection region, which remember will be plus or minus t of 0.005, because alpha has to be divided by 2, and 19 degrees of freedom. And you look to the table and you should check this by yourself. This is plus or minus 2.861. The exact same table we just did right now. So here you can check it. Is you have 19 degrees of freedom, which is this, and 0.005 is this value right here, 2.861. So then you draw the rejection region, just like we have done before. You have 0. This is minus 2.861, 2.861. So again, you're here, you'll reject it. You're here, you'll reject it too. So this is the rejection region. So is this, and this is the fail to reject. All right, so the value for T star is negative 1.5, which clearly is somewhere here. So T star is negative 1.5. It's not in the rejection region, so therefore the conclusion will be again fail to reject HO, which means that there is mu1 is equals to mu2, which means that there is no difference between the two, or actually there is no evidence to reject the claim that there is no difference. However, Burger King, remember, they claim that the amount of fat is less, but we just show that there is no difference. So therefore the appropriate thing to write will be there is not enough evidence to support BK's claim about the amount of fat. And that's it. Okay. Well, that was it for the rejection region. What about the p-value? So remember, for the p-value, step 1 and step 2 are exactly the same. Step 3, the p-value is going to be twice the probability that t is greater than the absolute value. So that will make this positive. If we look to the table, 1.5 is between these two. So all you have to do is pick something between 0.50 and 0.100. What's a number between those two? Well, let's say 0.06. So then you say this is 0.06. Multiply by 2, this will give you 0.12. Then step 4, you're going to compare the p-value, which is 0.12. Alpha was 0.01. Clearly this is bigger, and that means again fail to reject HO. And then you can do the same thing with a calculator, or the p-value will be twice TCDF. The lower bound is 1.5, the upper bound is 1000, and then you have 19 degrees of freedom, and this equals to 0.15, which clearly is going to be bigger than alpha, which was 0.001. So therefore it doesn't matter if you use the table or you use the calculator. The conclusion is the same. All right, so you can see this is very, very similar to all the stuff we've done before. Now, in this chapter, remember the main difference so far is that you have two samples. And you recall in chapter 7, we did confidence intervals for one sample. So now we're going to do an example for confidence intervals with two samples. All right, so the question clearly says a confidence interval for mu1 and mu2. Alpha is 0.05 because we want a 95% confidence interval. We have the same information. X1 bar, remember, was equals to 80. X2 bar was equals to 84. and 1 was equals to 25, n2 was equals to 20, s1 was equals to 10, and s2 was equals to 8. Now, just like in chapter 7, so you may want to go back and check like 7.2, where for the step 1, when it comes to confidence intervals, the first thing you do is you divide alpha by 2, which in this case it will give you 0.025, and then we'll find t of 0.025 with 19 degrees of freedom, which is 2.093. I think you should check that value. Then if you recall for step 2, okay, so this was back on the day, for step 2 you need to find the margin of error, which before was t of alpha over 2 times s divided by the square root of n. Well, so now in step 2, the margin of error is going to be t of alpha over 2 with degrees of freedom, which we already got, this value right here. But you're going to multiply times, now it's going to be s1 squared over n1 plus s2 squared over n2. So therefore in our case, this is 2.093 times the square root of 10 squared over 25 plus a squared over 20, which is equals to 2.093 times 2.6832a. You should check this. So this part is equals to this, and when you multiply, this gives you 5.616. So let's say this is 5.6. Now remember from before, in step 3, you did x bar plus or minus e. So now here, it's going to be x1 bar minus x2 bar plus or minus e, which in our case, it will be 80 minus 84 plus or minus 5.6, or minus 4 plus or minus 5.6. Therefore, mu1 minus mu2, so it's exactly the same thing we did before. You're going to add and subtract this. So minus 4 plus 5.6 is equals to 1.6, and this is minus 9.6. So this is the confidence. Now, the thing that is different here and that is very important, actually the most important part of this specific interval is this. You are looking, okay, so you are looking for 0. And by that I mean, does the interval contains the number 0, which in this case it does, because notice you go from a negative to a positive. So you go from a negative to a positive, you have to go through 0. Why is that important? Because if this is equals to 0, this implies that mu1 minus mu2 is equals to 0, which implies that mu1 is equals to mu2, which implies that there is no difference. So this is a different way to check the claim. This is less formal than the hypothesis testing, but this is another way. So this is the part that is new and that is very, very important. Once you do the confidence, you have to check if 0 is there. And if it is, it means this. This is something you didn't have to worry about in chapter 7, but in chapter 9 you do. And that's it for 9.1. Again, just to recap, this chapter 9 is essentially chapter 7. in chapter A, except that instead of one sample, you have two samples now.